All right, so with covalent bonding, what was the key word that we like to use?
Share.
They like to share, so deals with sharing of electrons, okay? So remember, those electrons are very manipulatable in the sense that sometimes you can, like, they want to be in those perfect little octets and show that there's 8 around it, but in the situation of polyatomic ions, they like to do kind of wacky stuff anyways, okay? Now the deal with covalent bonding is that both electronegativities of the substances or of the atoms involved are really, really high, okay? So both electronegativities are high. So, sharing is the only option. Okay, and don't forget as well, as a result, okay, these are always those nonmetals. Nonmetals have the highest electronegativity, so when they get together, they like to do this covalent bonding, and then that's what also kind of makes them those molecular compounds. Okay, now, basically what happens in terms of like an actual structure, covalent bonding creates something called a covalent network. Okay, so this is also a 3D arrangement linked by strong covalent bonds. All right, so these ones, on the other hand, if they are like super duper covalently bonded atoms, okay, quite often they're going to be really difficult to separate because everybody's sharing electrons, and there's so many atoms that are basically involved to like share those electrons that it's going to be difficult to break those bonds, okay? So a good example of this, and I'm going to try to draw this as best as I can, okay? Think of carbon, okay? Diamond is like the hardest substance on Earth, and it's really difficult to just kind of melt down and kind of like treat it easily, okay? You have to add a lot of heat and pressure to like kind of alter it. So otherwise, carbon, remember, it has 4 electrons around it. So when you're talking about a carbon to carbon to carbon to carbon molecule, okay, this is what this would look like. Oh my gosh, this is going to be so ugly. Okay, so then another carbon can kind of show itself up there. Okay, so I know this is really difficult to kind of draw and kind of organize, but basically what's happening is that all of these carbons are just gonna like repeat, and they basically make their own little covalent network that kind of makes like this big huge spider web of just like shared electrons with those atoms kind of fit in there. So if you kept going on, carbon can just go on forever because it can just constantly link and link and link and link to itself because it has 4 electrons around it that it can easily share. Okay? Sound good?